5 seconds, it's traveling at only 11 feet per second, then find an equation. So this is writing an exponential equation. They gave us 2 points. They sort of hid them. They are 2, 58. And 5, 11. And so you'll recall that in order to write the equation for an exponential growth, you have to plug in both points into y equals a b to the x. So that's 58 equals a times b squared. And 11 equals a times b to the 5th. What do we do to those 2 equations to solve this system? Do you remember? Divide, yes. So not a classic substitution elimination. So 58 divided by 11, I'm afraid of the decimal, so I'm just going to leave it 58 elevenths. Your a's cancel, and it becomes b to the what power? -3rd, exponent rules. Very good. 2 minus 5 is -3. So to solve for b here, what do I raise both sides to? Close. Unless I missed a word. Andrew? -1/3. See, does everyone see how this is not an exponential equation? My variable is not in the exponent. So I don't take the log of both sides. If it was this, then I would take the log of both sides because my variable is in the exponent. That's not what's happening here. So this is where I just raise it to the reciprocal, -1/3 on both sides. And I get b equals the number, and I'm going to stop there. You would find your value for b, and then you go back and you plug b in and calculate a. Do you remember that? Familiar? Okay. Number 3 here. Gives us a function and asks us to algebraically determine the solution to g of x equals 22. Let me clear something up. It is not telling you to find g of 22, is it? That would mean plug in 22 for x. That is not what it's telling us to do. It is saying find when g of x equals 22. So I'm going to replace this with a 22. And then solve that. Okay? This one is an exponential equation because the variable is in the exponent. What do I have to do to both sides first? Andrew? Not yet. Nate? Add the 3 first, and then we'll do the log, okay? You could do the natural log on both sides, you could do plain old log on both sides, or what would make the most sense would be to do a log with a base of 1/5. Very good. And I'm going to stop there with that one. You can finish that. Number 4. Here's the function. Why is x equaling 0 not in the domain? If I did plug in an x of 0, what's 0 minus 4? -4. Why is log base 2 of -4 going to give me an error on my calculator? Very good. You can't take the log of a negative. Okay. Number 5, and here's a perfect example. They want us to evaluate log base b of 40. They didn't make the base a number because they didn't want you to be able to type it into your calculator. But we are going to split up 40 into 5s and 2s because that's all we know. So when I rewrite 40, I'm going to first rewrite it as 4 times 10. And 4 is the same thing as 2 times 2 times 10 is the same thing as 2 times 5. And now it's all in terms of 2's and 5's, so I can expand. That's going to be log base b of 2 plus log base b of 2 plus log base b of 2, right? Multiplication turns to addition. Plus log base b of 5. And each of those has a value. Log base b of 2 is 0.55. And I've got 3 of them, so there's 0.55 times 3 plus 1.28. Okay, and on the last one here, we're given a bank account formula. Essentially, they're asking us how long until it's worth $500. So this is 500. And then we would solve the exponential equation, kind of like we've been doing. So for homework, I want you to finish these problems. Okay, we've set them all up. And on the front side, I just want you to read the word problem, figure out what variables equal what numbers, and plug them in. Okay? And then you don't have to solve this. Just tell me what each variable stands for and plug it in.